In electrical machines 2, the first topic is synchronous generator. Synchronous generator means alternator. In alternator, we have to find the regulation. So, voltage regulation can be determined by using the formula E phase minus V phase divided by V phase into 100. E phase means induced EMF in an alternator. So we have to find the induced EMF in an alternator. And second one is V phase. V phase means which is a terminal voltage. So terminal voltage can be measured by using any meters, which means voltmeter. So finding the phase value is simple, but finding the value of E phase is difficult. So for finding this E phase, we are going for three different methods. First one is EMF method. EMF or synchronous impedance method. Second one is MMF or ampere turns method. Third one is ZPF method. And fourth one is modified ASA method. So first of all, now we are going to see how we are getting the EMF value by using these methods. So first one is EMF method. In EMF method, the induced EMF per phase is equal to square root of V phase cos phi plus IA RA the whole square plus V phase sin phi plus or minus IA x is the whole square. So this plus or minus sign indicates change depends on the power factor value. Power factor means the power factor can be lagging or leading. For leading power factor, we can take it as a minus sign. For lagging power factor, it is a plus sign. For lagging power factor, the equation comes V phase cos phi plus IA RA the whole square plus V phase sin phi plus IA x is the whole square under square root. And next one is for this values find by using the formula. V phase means which is VL by root 3. VL means line voltage which is given in the problem itself. And next one is IA. IA is line current IL. That is kVA divided by root 3 VL. Alternator normally specified in kVA rating. So the kVA rating of the alternator is given, and from this we are getting the value of line current. And next one is XS. XS means synchronous reactance. So for synchronous reactance, the formula is square root of Zs square minus Ra square. Zs means which is synchronous impedance. So by means of finding the synchronous impedance, we are getting the value of E phase. That is why the method is named as synchronous impedance method or EMF method. So synchronous impedance values VOC divided by IAC, and these two values must be get for same value of the field current. And next one is MMF method. MMF are also known as ampere turns method. And from this method, first we have to calculate the field current value. The field current required to produce the induced EMF E phase value. So for IF, the formula is IF1 square plus IF2 square minus 2 IF1 IF2 cos of 90 plus or minus 5. Again this plus or minus 5 indicates for our difference for lagging and leading power factor. IF1 means the field current required for the voltage for producing the rated voltage. IF2 means field current required for rated armature current. And by drawing the graph, we can get these two values. So for solving the problems on MMF method, we have to go for a graph which consisting of open circuit characteristics and then short circuit characteristics. From OCC, we can get the value of IF1. From SCC, we can get the value of IF2. And after finding this IF, we can get the induced EMF E phase from the graph. And then again by using the formula E phase minus V phase divided by V phase into 100, we can get the value of regulation. And then ZPF method. ZPF method, first of all we have to draw the ZPF triangle. Then only we can able to solve the problem. How can we draw this ZPF triangle means, first of all we need two different test data for this ZPF method. First one is open circuit characteristics, which is drawn between field current and the open circuit voltage. And then zero power factor characteristics. Zero power factor test means, and by applying the pure inductive load, we have to get the terminal voltage and then field current. So for different field current, we can get the different value of voltage, and we can draw the that is zero power factor test characteristics. And after this, we have to draw the ZPF triangle. So how can we draw this triangle means, first of all we mark the value dot P. This P indicates the rated voltage. Rated voltage of a machine. The corresponding line point on the ZPF characteristics indicates the point P. From point P we have to draw the line PQ. This length of PQ is equal to length of OA, and this length and this PQ length both are same. So we have to draw this. And after this we have to draw the tangent line or yard line from the point O. So this point from point Q we have to draw the parallel line to the yard line, and this cuts the OCC at point R. Join R and P, and this PQR triangle is known as ZPF triangle. And from the R you draw the perpendicular line which cuts PQ at point S. The length of RS indicates the IAXL drop, that is leakage reactance drop. So if you know the leakage reactance drop, then you can find the induced EMF per phase under leakage reactance. So the formula becomes V phase cos phi plus IA RA the whole square plus V phase sin phi plus IA XL the whole square. Instead of in EMF method we are substituting as XS, and here it will be changed as XL. And the field current, now we are getting the induced EMF, the E phase 1, and this E phase 1 shows the corresponding field current IF1. The IF1 is the field current corresponding to E phase 1. And next one is length of PS. Length of PS into current scale shows the value of field current IF2. And after getting this IF1, IF2, we solve with the problem as IF is equal to square root of IF1 square plus IF2 square minus 2 IF1 IF2 cos of 90 plus or minus 5. And again we are getting the IF, and that IF gives the rated induced EMF voltage E phase. And if you know the E phase value, then we can calculate the percentage regulation. E phase minus V phase divided by V phase into 100.